Tonight, we travel across 100,000 light years, through dust, light, and silence, to explore the story of our home galaxy, the Milky Way. If you enjoy learning in the quiet hours, follow the channel and share what you'd like to discover next. When I look up at the night sky, I see that faint river of light curving overhead. It looks fragile and still, yet it is the edge of something enormous. We live inside that band of stars, halfway between its crowded heart and its distant rim. The light we see is our own galaxy, seen from within. The Milky Way is vast, but not infinite. It stretches about 100,000 light-years across and holds hundreds of billions of suns. Around those suns orbit countless planets, moons, and fragments of rock and ice. Each one follows the pull of gravity through a shared sea of stars. To understand this home of ours, we must return to its beginning, nearly 14 billion years ago. The universe had just been born. There was no light yet, only hydrogen, helium, and darkness expanding outward. Imagine that first moment, not an explosion in space, but the birth of space itself, carrying with it all the seeds of what would become galaxies, stars, and worlds. Over hundreds of millions of years, gravity gathered the gas into clouds. These weren't ordinary clouds like those in our sky. They were vast and diffuse, stretching across light years, yet dense enough that gravity could slowly pull them tighter. Within these clouds, the first stars flickered into existence. They were giants, massive beyond anything we see today, burning fiercely and fast. These first stars lived short, brilliant lives. Without the heavier elements that later stars would have, they could only fuse hydrogen and helium. When their fuel ran out, they didn't fade quietly. They exploded in tremendous supernovae, each one bright enough to briefly outshine entire galaxies. In those explosions, new elements were forged: carbon, oxygen, nitrogen, iron, and everything else that would one day make up planets and people. These elements scattered outward, mixing with the hydrogen and helium that still filled space. Our galaxy grew from those early gatherings of matter. Small clouds of stars collided, merged, and began to spin together. Picture two streams of water meeting and swirling as they flow downhill. Gravity worked in much the same way, drawing separate clouds into a single rotating mass. As the rotation increased, something remarkable happened. The gas and stars flattened into a disk, like pizza dough spinning, in the air. Inside that disk, new generations of stars formed from enriched material. This second generation had access to the elements made in earlier stars. They could form rocky planets, complex molecules, and eventually life. In time, their light became the glow of the Milky Way we see today. When I imagine this, I picture a whirlpool of starlight taking shape in slow motion, each rotation measured in millions of years. The first spiral arms emerged like ripples on water, patterns created by gravity and motion. The arms weren't fixed structures, but waves moving through the rotating disk, areas where stars bunched together, making the spiral pattern visible. The Milky Way didn't form all at once. It grew through mergers, absorbing smaller galaxies that wandered too close. Each merger added new stars and gas, building the galaxy layer by layer. Some of those early galaxies can still be traced today. Their stars orbit the Milky Way in unusual patterns, remnants of ancient collisions. The halo of old stars surrounding our galaxy tells this story of gradual assembly. Each cluster a memory of something smaller that once existed independently. As the galaxy took shape, its rotation created stability. The outward momentum of spinning balanced the inward pull of gravity, preventing collapse. This balance continues today. Every star, every cloud of gas, every atom moves in harmony with the whole, held together by forces that operate over distances so vast we can barely conceive of them. At the same time, the galaxy's structure became more complex. A central bulge formed, packed with older yellow-red stars. Spiral arms extended from this bulge, traced out by younger blue-white stars. Between the stars, vast clouds of dust and gas drifted, dark against the glow, waiting to collapse into new suns. The Milky Way became what astronomers call a barred spiral galaxy. It has a central bar of stars with spiral arms extending from the bar's ends. If you could watch the galaxy's history in time-lapse, you would see a slow dance of mergers and transformations. Small galaxies fall inward, mix with ours, and become part of the whole. The shape of the Milky Way is the result of billions of years of such motion, each merger leaving traces that astronomers can still detect today. Stars from those smaller galaxies now orbit our own, their paths revealing their foreign origin. The formation of the Milky Way wasn't a singular event, but an ongoing process. Even now, new collisions are coming. The galaxy continues to grow, to change, to evolve. What we see when we look up is merely one frame in an immense story that stretches back to the dawn of time and forward into a future we can only imagine. At the center of the galaxy lies something extraordinary, hidden behind clouds of dust and gas. Astronomers call it Sagittarius, a star, written as Sagittarius A**. It is a supermassive black hole containing approximately 4 million times the mass of our Sun, compressed into a region smaller than our solar system. We cannot see it directly. Black holes emit no light, but we know it is there because of the way nearby stars race around it. These stars move at thousands of kilometers per second, their paths tracing the invisible weight that holds the center together. By carefully tracking their orbits over many years, astronomers have mapped the black hole's position and measured its mass with remarkable precision. One star, called S2, takes only 16 years to complete its orbit around the black hole. At its closest approach, it moves at nearly 3% the speed of light, faster than anything else we've measured in our galaxy. The black hole at our galaxy's center is relatively quiet compared to those in other galaxies. It doesn't consume large amounts of matter or produce brilliant jets of radiation. Instead, it sits dormant most of the time, occasionally flaring when gas clouds or asteroids fall into it. These flares can briefly brighten the region by hundreds of times, visible across multiple wavelengths of light. Around that center, the disk of the galaxy stretches outward. Old red stars fill the inner bulge, packed so densely that their light merges into a golden haze. Farther from the core, younger blue stars trace the spiral arms, lighting them from within. Between them lie vast regions of interstellar dust, dark and silent, where new stars are waiting to be born. The dust absorbs visible light, but glows softly in infrared, revealing complex structures invisible to our eyes. The galaxy's structure is layered, like an onion. At its heart lies the black hole and the dense nuclear bulge. Surrounding that is the thick disk where most stars reside. Extending farther out is a thin disk of gas and dust. And enveloping everything is a vast spherical halo of old stars and dark matter, reaching far beyond the visible light of the galaxy. Each layer has its own character, its own history, its own role in the galaxy's evolution. Our own sun sits quietly within one of the smaller arms called the Orion Spur, also known as the Orion Cygnus Arm. It is a modest neighborhood, calm and bright, about 27,000 light-years from the center, not too close to the crowded, turbulent core, and not too far out in the sparse, cold edges. It is, by most measures, a comfortable place to be. The sun travels around the galaxy once every 230 million years, moving at roughly 220 kilometers per second. It has completed that orbit only about 20 times since it was born 4.5 billion years ago. The last time our solar system was in this part of its orbit, dinosaurs were just beginning their reign on Earth. The next time we return to this position, they will have been gone for hundreds of millions of years, and whatever life follows us will look up at the same stars from entirely different eyes. Every star you can see on a clear night belongs to this same vast structure. Together, they drift through space like glowing grains in an immense current. To the human eye, it seems motionless, yet the entire galaxy turns slowly, carrying us all with it. The stars we see tonight are not where they were when their light began its journey toward us. They have moved, we have moved, yet the patterns remain recognizable, because the distances are so great that motion becomes invisible. The Milky Way is not a rigid object, but a living system, constantly cycling matter through generations of stars. Clouds of hydrogen collapse to form new stars. Those stars burn, die, and return their elements to space. The galaxy recycles itself over and over, creating complexity from simplicity, building the periodic table one supernova at a time. The oxygen in your lungs and the calcium in your bones were forged in ancient stars that once shone within these same spiral arms. When those stars exhausted their fuel and exploded, they scattered their contents across light years of space. Those atoms drifted in clouds for millions of years before gravity gathered them again, this time into the disk of gas that would become our solar system. Every breath you take connects you to that cycle, to the deep history of the galaxy itself. When I think of that, I feel the distance between ourselves and the universe disappear. We are not separate from the Milky Way. We are its continuation, built from its dust and carried on its rotation. To look at the galaxy is to look at our own origin, our own substance, written large across the sky. The light we see is not just photons from distant suns. It is a message from the past, a reminder of where we came from and what we are made of. The story of the Milky Way is also the story of us and every living thing that has ever existed on Earth. The carbon in our cells, the iron in our blood, the phosphorus in our DNA, all of it was made in stars. We are, quite literally, stardust that has learned to think and to wonder about its origins. In knowing this, we complete a circle, bringing the matter of the universe to a state of self-awareness. Most of the galaxy's mass is invisible. Surrounding the disk is a vast halo of dark matter, a kind of unseen glue that holds everything together. Without it, the outer stars would drift away into space. their orbital speeds too great for the visible matter alone to hold them. Though we cannot detect dark matter directly, we feel its pull in the way the galaxy moves, in the speeds of stars that orbit far from the center. Dark matter makes up roughly 85% of the galaxy's total mass. It does not emit, absorb, or reflect light, making it invisible to every telescope we have built. Yet its gravitational effects are undeniable. By measuring how fast stars orbit at various distances from the galactic center, astronomers discovered that the orbital speeds remain high, even far from the core, much higher than visible matter alone could explain. This discrepancy revealed the presence of a massive dark halo extending far beyond the luminous disk. The nature of dark matter remains one of the great mysteries of modern astronomy. Is it made of exotic particles that rarely interact with ordinary matter? Is it something we have not yet imagined? We do not know. What we do know is that it shapes the structure of galaxies, guides their evolution, and makes possible the cosmic web that connects everything in the universe. Without dark matter, galaxies like ours could not have formed. The early universe would have remained too smooth, too uniform, for gravity to gather matter into stars and galaxies. Beyond the stars and dust lies the quiet halo of ancient globular clusters, each one a swarm of old suns orbiting the center. Some of these clusters formed before the Milky Way itself fully assembled, more than 12 billion years ago. They contain hundreds of thousands of stars packed into spheres only a few dozen light years across. From Earth, they appear as fuzzy patches of light, but through a telescope, they resolve into dense concentrations of stars, so tightly packed that near their centers, stars pass within light days of each other. These globular clusters are fossils of an earlier cosmos. Their stars are metal poor, containing only trace amounts of elements heavier than helium. This tells us they formed from nearly pristine gas, before generations of supernovae had enriched the universe with carbon, oxygen, and iron. By studying their ages and compositions, astronomers can trace the history of the Milky Way's formation, piece by piece, cluster by cluster. The globular clusters orbit the galaxy along long, elliptical paths that carry them high above and below the galactic plane. Unlike the orderly, circular orbits of stars in the disk, these clusters move at steep angles, plunging through the galactic center and swinging back out to the halo. Their orbits are remnants of the chaotic early days of the galaxy, when smaller systems merged and stars were scattered into wide, random paths. Some clusters likely formed within dwarf galaxies that the Milky Way later absorbed. When a small galaxy falls into ours, its stars are torn away by tidal forces, but its globular clusters can survive, continuing to orbit as reminders of something that once existed independently. By tracing the orbits of these clusters, astronomers can reconstruct the Milky Way's merger history, identifying which clusters came from which ancient companions. Our galaxy has companions even now. Two of them, the Large and Small Magellanic Clouds, are visible from southern latitudes as pale patches of light. They are dwarf, irregular galaxies orbiting our own, slowly twisting streams of stars across the sky. The Large Magellanic Cloud contains about 30 billion stars, making it a substantial neighbor. The Small Magellanic Cloud is smaller, with perhaps 3 billion stars, but both are close enough that their gravity interacts with the Milky Way. These companion galaxies are slowly being torn apart by tidal forces. Long streams of gas and stars stretch between them and the Milky Way, pulled out like taffy by the difference in gravitational pull from one side to the other. These streams, called the Magellanic Stream, wrap around the Milky Way like ribbons, containing millions of solar masses of hydrogen gas. Eventually, over billions of years, the Magellanic Clouds will likely merge with the Milky Way, their stars added to our own. The Milky Way has consumed others in the past, their remnants stretched into faint rings and arcs that still shimmer around us. One such remnant is the Sagittarius dwarf elliptical galaxy, currently in the process of being tidally disrupted. Its stars wrap around the Milky Way in a looping stream that passes above and below the galactic disk. Each time it orbits, more of its stars are stripped away, joining the halo of the Milky Way. In a few billion years, it will be completely dispersed, its stars indistinguishable from the rest of the halo. If you could watch the galaxy's history in time-lapse, you would see a slow dance of mergers and collisions. Small galaxies fall inward, mix with ours, and become part of the whole. The shape of the Milky Way is the result of billions of years of such motion, each encounter leaving traces we can still detect. The outer halo is filled with streams and shells of stars, each one a fossil of a galaxy that no longer exists as a separate entity. Even now, new collisions are coming. The Sagittarius dwarf galaxy is being torn apart, its stars wrapping around our own in a tidal stream. Farther away, the great spiral of Andromeda is drifting toward us at about 110 kilometers per second. In approximately 4 billion years, the two galaxies will meet and merge. They will not crash violently. Stars are so far apart that actual collisions between individual stars are almost impossible. Instead, the galaxies will pass through each other like two clouds of smoke intermingling. Over time, gravity will cause them to fall back together. They will pass through each other again and again, each passage drawing them closer as friction and gravitational interactions drain their orbital energy. After several billion years of this cosmic dance, the two galaxies will settle into a single, larger structure. The spiral arms will be disrupted, replaced by a more elliptical shape as the ordered rotation of the disks is scrambled by repeated interactions. When that happens, the night sky of any surviving world will glow with unfamiliar constellations. Stars that once belonged to Andromeda will shine overhead, mixed with stars from the Milky Way. The black holes at the centers of both galaxies will spiral toward each other, eventually merging into a single supermassive black hole weighing about 10 million solar masses. This merger will release gravitational waves powerful enough to ripple across the universe, detectable by future observatories designed to measure such cosmic events. The Milky Way will no longer be a single river of light, but a sea of stars stretching across all directions. For a time, the sky will be bright with star formation, as colliding gas clouds trigger bursts of new suns. But eventually, the gas will be exhausted or blown away, and star formation will slow. The merged galaxy, sometimes called Milkomeda or Milkdromeda, will gradually age, its stars burning out one by one, until only the longest-lived red dwarfs remain, glowing faintly in the darkness. Even before that far future, our galaxy continues its quiet transformations. The outer disk is slightly warped, bending upward on one side and downward on the other. This warp is likely caused by the gravitational pull of the large and small Magellanic Clouds as they orbit. Their combined mass tugs at the Milky Way's disk, sending ripples through it that travel outward like waves across water. The warp extends for tens of thousands of light years, a gentle twist in the plane of the galaxy. Ripples move through the disk, stirred by those smaller galaxies that orbit nearby. Everything about the Milky Way is in motion, though we feel none of it. The stars drift, the gas flows, the dark matter swirls invisibly around it all. Even the shape of the galaxy changes over time, responding to internal dynamics and external influences. What we see tonight is only one moment in a continuous evolution that has been unfolding for billions of years. From Earth, we see only a narrow slice of this vast system. Dust clouds block our view of the distant center, making it impossible to see the full structure of the galaxy in visible light. The plane of the Milky Way appears as a dark band across the sky, not because there are no stars there, but because dust absorbs their light. This dust, made of tiny grains of carbon and silicates, scatters blue light more than red, reddening the stars we can see and dimming them significantly. Yet with radio and infrared telescopes, astronomers have learned to see through the veil. Radio waves pass through dust almost unimpeded, revealing the cold hydrogen gas that fills the disk. Infrared light can penetrate where visible light cannot, showing us the warm dust around star-forming regions and the cool red stars of the galactic bulge. Together, these different wavelengths of light paint a complete picture of the galaxy, showing its spiral arms, its central bar, and the vast halo surrounding it all. The European Space Agency's Gaia mission has mapped more than 1 billion stars, creating a three-dimensional portrait of our galaxy. By precisely measuring the positions, distances, and motions of these stars, Gaia has revealed the Milky Way in unprecedented detail. We now know the shapes of the spiral arms, the structure of the halo, and the motions of stars with accuracy unimaginable just a few decades ago. This data will keep astronomers busy for generations, revealing new patterns, new structures, new insights into how the galaxy works. The more we learn, the more dynamic the Milky Way appears. It is not a static disk of stars, but a restless ocean of motion and change. Waves of gravity ripple through it, caused by passing dwarf galaxies and the uneven distribution of matter. Clusters drift apart and reform. Supernovae explode like sparks, sending shock waves through the gas around them. Each of those shocks may give birth to new stars, continuing the endless cycle of creation and destruction that drives the galaxy's evolution. To the human heart, there is comfort in this continuity. Nothing here is wasted. Every end becomes a beginning. Even when a star dies, its light travels onward, reaching across time to fall softly on our world. The photons that enter your eyes tonight began their journey thousands or tens of thousands of years ago, traveling through the emptiness of space to this one moment of perception. In that sense, to see is to touch the past, to connect directly with distant places and times. When you look up tonight and see that silvery trail across the sky, remember that it is both distant and intimate. Those stars are our ancestors in a literal sense. They created the elements from which we are made. Their light is our history, written in photons that have crossed vast gulfs of space to reach us. To fall asleep under them is to lie within the arms of the galaxy itself, cradled by the same forces that shape stars and planets, moons and worlds. The galaxy does not care whether we see it or not. Yet it has made us capable of seeing, capable of wondering, capable of asking what it all means. In that sense, we are the universe looking back at itself, matter organized into a form that can contemplate its own existence. The Milky Way is not just a place, it is a process, an ongoing story in which we play a small but conscious part. The Milky Way seems quiet when we look up at night, but it is never still. Every part of it moves. Each star, each cloud, even the invisible matter around it follows its own path through space. What appears frozen above us is a slow and graceful rotation taking place over hundreds of millions of years. Our solar system rides along with this motion. The Sun and all its planets travel around the galactic center at roughly 220 kilometers per second. This seems impossibly fast. Yet because everything around us moves the same way, the sky above remains still. The stars maintain their familiar patterns, changing only over timescales far longer than human history. It is a journey so vast that one full orbit takes more than 200 million years. The last time our solar system was in this part of its orbit, the first dinosaurs were walking the Earth. Mammals had not yet evolved. The continents were joined in a single supercontinent called Pangaea. Since then, we have traveled all the way around the galaxy and returned to approximately the same position, while on Earth, entire eras of life have risen and fallen. Continents have drifted apart, oceans have opened and closed, mountains have been thrust up and worn down, and life has transformed the planet beyond recognition. When I imagine that timescale, I picture our world as a small passenger on a long and patient voyage. Each night, sky is just one snapshot from a journey that began before our species existed and will continue long after we are gone. The galaxy does not measure time in days or years, but in the slow turning of its spiral arms, in the rise and fall of star-forming regions, in the gradual drift of its companions through space. The Sun does not follow a perfect circle around the galactic center. It drifts slightly up and down through the galactic plane, rising and sinking every 30 million years or so like a gentle wave. These oscillations are caused by the combined gravity of all the matter in the disk, which pulls the Sun back toward the plane whenever it wanders too far above or below. Think of it as a marble rolling in a shallow bowl. It may rise up the sides, but gravity always brings it back to the center. These gentle crossings through the galactic plane have sparked speculation among scientists. Some have wondered whether passing through denser regions of the galaxy might influence conditions on Earth. When our solar system moves through areas with more interstellar dust or gas, cosmic radiation levels could increase slightly. Nearby supernovae might become more common. Over millions of years, these variations could perhaps affect Earth's climate or the evolution of life. The evidence for such connections remains uncertain, but the idea reminds us how connected we are to this larger motion. We think of Earth as isolated, protected by distance from the rest of the galaxy. Yet we are part of a system that extends across thousands of light years. influenced by forces that operate on scales we can barely perceive. Every breath we take, every heartbeat, happens within this cosmic context. If we could step outside the Milky Way and look down from above, we would see a great spiral of light turning slowly in the dark. The spiral arms are not fixed structures, but patterns of motion, like traffic jams that move through the flow of stars. As a density wave passes through the disk, gas clouds are compressed and new stars are born. When those young stars shine, they light up the spiral arms from within, outlining their shape for a little while, before fading into the background again. Our sun drifts within one of the smaller branches of this pattern, the Orion Spur. It is a quiet stretch of galactic suburb, far from the crowded center but close enough to share its warmth. Around us, other stars move on similar paths, each one following its own rhythm within the great rotation. Some stars orbit faster, overtaking us. Others lag behind. Over millions of years, the neighborhood slowly changes as stars drift past each other like ships passing in the night. The Milky Way's spiral arms are filled with regions of starbirth. Inside giant clouds of molecular hydrogen, gravity slowly gathers material into knots. These clouds are cold, only a few degrees above absolute zero, and immensely vast, stretching for hundreds of light years. Within them, denser regions begin to collapse under their own weight. As the gas falls inward, it heats up, glowing first in infrared, then in visible light as nuclear fusion ignites at the core. A new sun is born, surrounded by disks of dust that may one day form planets. The intense radiation and stellar winds from the young star blow away the surrounding gas, creating a cavity in the cloud. If the star is massive enough, its ultraviolet light ionizes the remaining gas, making it glow in brilliant reds and blues, what we call an H2 region, a nebula lit from within by newborn stars. When I think of those nurseries, I imagine floating in a silent ocean of mist, watching faint glows where light tries to pierce through. The Orion Nebula is one such place, only about 1,300 light-years away. Even with a small telescope, you can see its soft shimmer. Inside, hundreds of young stars are forming right now, the next generation of the galaxy coming to life. Some of those stars will live for billions of years, outlasting our own sun. Others, the most massive ones, will burn fiercely for only a few million years before exploding as supernova. The Milky Way has been creating stars like this for more than 13 billion years. Its current pace is slower now than in its youth. Perhaps 1 or 2 solar masses worth of new stars form each year across the entire galaxy. Long ago, during the peak of cosmic star formation, about 10 billion years ago, the rate was much higher. The galaxy has matured, balancing birth with death, recycling the material of old stars to make new ones. Every star that dies returns its elements to space. When a massive star reaches the end of its life, its core collapses in a fraction of a second, rebounding in a tremendous supernova explosion. In that brief moment, temperatures and pressures reach levels high enough to forge the heaviest elements: gold, platinum, uranium, and others. The explosion scatters these elements outward at thousands of kilometers per second, enriching the interstellar medium. Over time, those elements drift into clouds that will form new suns. The cycle never truly ends. Every breath we take carries atoms forged in stars that burned billions of years before the Earth existed. The iron in our blood was made in a supernova. The The calcium in our bones formed in the dying moments of a massive star. We are, quite literally, made of stardust, connected to the deep history of the galaxy by the very substance of our bodies. Beyond the bright disk lies the halo, a vast sphere of ancient stars surrounding the galaxy. Many of these stars were once part of smaller galaxies that merged with ours long ago. Their orbits are long and looping, carrying them far above and below the plane before returning again. Each one is a relic of the Milky Way's early history, a memory written in light and motion. Surrounding everything is the mysterious dark matter halo. We cannot see it, but its gravity holds the galaxy together. Without it, the outer stars would move too fast to remain bound. They would drift away into intergalactic space, and the Milky Way would gradually dissolve. We measure dark matter's presence by observing how stars orbit. The fact that they move faster than visible matter alone can explain tells us that most of our galaxy's mass is invisible, detectable only through its gravitational pull. Even the shape of the Milky Way is not perfectly flat. The outer edges are gently warped, bending upward on one side and downward on the other. Astronomers believe this twist is caused by the pull of nearby companion galaxies, especially the Magellanic Clouds. Their gravity tugs at the disk, sending ripples through it that travel outward like waves across water. These ripples reveal how dynamic and interconnected the galaxy truly is, responsive to every nearby mass, every passing dwarf galaxy. Those companions are not the only ones. Dozens of small dwarf galaxies orbit the Milky Way, most of them so faint they were only discovered in recent decades. Some contain only a few thousand stars, barely more luminous than a bright globular cluster. Others, like the Sagittarius dwarf galaxy, are currently being pulled apart, their stars stretched into long arcs around our own. These slow interactions continue to reshape the Milky Way even today, adding new stars and gas to our galaxy's growing mass. In the future, an even greater event awaits. The Andromeda Galaxy, our nearest large neighbor, is moving toward us at more than 100 kilometers per second. Although it lies more than 2.5 million light-years away, its approach is steady and inevitable. In about 4 billion years, the two galaxies will begin to merge. The collision will not be violent in the sense of stars crashing into each other. Space is so empty that actual stellar collisions will be extremely rare. Instead, gravity will stretch and mix the two galaxies, drawing out long tails of starlight. Stars will be flung into new orbits, some escaping into intergalactic space, others settling into the merged galaxy's core. Gas clouds will collide and compress, triggering intense bursts of star formation. For a few 100 million years, the sky will be filled with brilliant young stars, blue and hot, born from the collision. Over time, the two galaxies will settle into one, perhaps becoming a large elliptical galaxy glowing softly in the dark. The spiral arms will fade, replaced by a smooth distribution of stars. The two central black holes will spiral toward each other, eventually merging and releasing gravitational waves that ripple across the universe. The merged black hole will weigh about 10 million times the mass of the Sun, forming the heart of the new galaxy. If anyone is there to see it, the sky will be filled with light. Andromeda will grow larger each night until its spiral arms dominate the heavens. Eventually, the two galaxies will combine, and the stars will form new patterns that no eye has ever seen. But this future is still billions of years away. For now, the Milky Way turns quietly, carrying us on our endless voyage through the cosmos. When we think about the Milky Way, it is easy to picture the stars alone. Yet, within those stars, something more intimate is always taking place. Every light we see in the night sky is the surface of a sun, and each one carries the story of matter turning into energy, of elements being forged, of creation and destruction happening on scales both vast and delicate. To understand our galaxy, we must look at how those stars live, how they change, and how they share their light with everything around them. The birth of a star begins in silence. Deep within clouds of cold molecular hydrogen, pressure slowly builds over millions of years. At first, nothing seems to happen. The cloud drifts through space, dark and invisible. But deep inside its densest regions, gravity takes hold. The gas falls inward, molecule by molecule, forming a core that grows hotter and denser with each passing millennium. Temperature and pressure rise steadily. When the core reaches about 10 million degrees, hydrogen nuclei begin to fuse into helium, releasing energy in the process. This energy pushes outward, balancing the inward pull of gravity. The cloud stops collapsing. A new light appears in the darkness. A star is born. Its surface glows at thousands of degrees, warming the space around it, beginning a journey that may last billions of years. Every star in the sky began this way, born from the slow collapse of gas, ignited by the pressure of its own weight. Some were born massive, bright, and short-lived. Others, like our Sun, burn steadily for billions of years. Each generation of stars changes the galaxy a little more. They enrich it with new elements, shaping the future of worlds that have not yet formed, leaving behind the building blocks of planets and life. When I look at the Milky Way, I like to imagine that each sparkle is part of a great cycle of transformation. The youngest stars shine blue and hot, pouring ultraviolet light into the surrounding gas. Middle-aged stars like the Sun glow yellow-white, steady and warm. The older stars appear red and cool, swollen giants nearing the end of their fuel. Between them lie countless stages of stellar life, from gentle dwarfs that will burn for trillions of years to massive supergiants on the edge of catastrophic collapse. Our own Sun is an ordinary star, about halfway through its lifetime. For the past 4.5 billion years, it has fused hydrogen in a stable rhythm, converting about 600 million tons of hydrogen into helium every second. The energy released in this process travels outward through the Sun's layers, taking hundreds of thousands of years to reach the surface, before streaming into space as light. That light reaches Earth in just over 8 minutes, warming our world, driving our weather, making life possible. Around the Sun, the planets and moons move through space, held in their orbits by its gravity, warmed by its steady glow. But even our familiar star will change. In about 5 billion years, when the hydrogen in its core is gone, the core will contract and heat up. Hydrogen in a shell around the core will begin fusing, releasing more energy than before. The Sun will expand into a red giant, swelling until it engulfs the inner planets. Mercury and Venus will be consumed. Earth, if it survives, will be a scorched, airless rock orbiting just beyond the Sun's swollen surface. The outer layers of the red giant Sun will drift away over millions of years, forming a soft, glowing shell of gas called a planetary nebula. the core that remains will shrink into a white dwarf, a dense ember about the size of Earth, but containing more than half the Sun's original mass. It will shine faintly for trillions of years, slowly cooling, a ghost of the star it once was. Eventually, after more time than the current age of the universe, it will fade to black, a dark cinder drifting through space. The same fate awaits billions of other stars in our galaxy, all those with masses similar to the Sun or smaller. They will live quietly, shine steadily, then fade into white dwarfs. But the largest stars burn with such furious energy that they cannot end peacefully. Their cores fuse heavier and heavier elements, carbon, oxygen, neon, silicon, building toward iron. When iron forms in the core, fusion stops. Iron cannot be fused to release energy. Instead, fusing iron requires energy, draining heat from the core. Without the outward pressure of fusion to support it, the core collapses in less than a second. Protons and electrons are crushed together into neutrons. The collapse halts suddenly when the core reaches nuclear densities, and the infalling material rebounds in a tremendous supernova explosion. For a few weeks, the dying star outshines all the other stars in its galaxy combined, visible across millions of light-years of space. Those explosions scatter heavy elements into space, seeding the clouds that will form the next generation of stars and planets. The iron in your blood, the gold in jewelry, the uranium in Earth's crust, all were made in supernova. These violent endings are essential to the galaxy's evolution, distributing the periodic table throughout the interstellar medium, enabling the formation of rocky worlds and complex chemistry. What remains after a supernova depends on the mass of the original star. For stars between about 8 and 20 solar masses, the core compresses into a neutron star, a sphere only 20 kilometers across, but containing more mass than the Sun. Neutron stars are so dense that a teaspoon of their material would weigh 1 billion tons on Earth. Some neutron stars spin rapidly, emitting beams of radio waves that sweep across space like a lighthouse. We call these pulsars, and they tick with extraordinary precision, some rotating hundreds of times per second. For the most massive stars, those with cores above about 3 solar masses, not even neutron degeneracy pressure can halt the collapse. The core continues to shrink, its escape velocity exceeding the speed of light. It becomes a black hole, a region of space-time so warped that nothing inside can ever escape. The black hole itself is invisible, but matter falling into it heats up and emits intense radiation before crossing the event horizon. These stellar mass black holes, scattered throughout the galaxy, are the endpoints of the most massive stars' lives. It is through these cycles of death and rebirth that the Milky Way evolves. The iron, oxygen, and carbon released by dying stars mix with the hydrogen and helium that fill the galaxy. New stars form from this enriched material, and they in turn create planets that could not have existed in the early universe. Life itself depends on this cycling of matter, on the supernova that scattered the elements we are made of, on the patient recycling that turned primordial gas into the complex chemistry of living things. Between those bursts of creation and destruction lies the quieter story of what fills the spaces between the stars. The interstellar medium is made of gas, dust, and cosmic rays, material so diffuse that even the best vacuum chambers on Earth are denser. Yet it is everywhere, forming the soft background against which stars shine. In places, the gas is hot and ionized, heated by supernova or young stars. In others, it is cold and molecular, the nurseries where new stars will one day be born. Inside that space, magnetic fields twist and flow. They guide charged particles along invisible paths, shaping the structure of gas clouds and influencing how stars form. These fields are difficult to detect, but they influence everything from the shape of supernova remnants to the birth of planetary systems. Even in emptiness, the galaxy hums with invisible motion, with forces we can barely perceive, but which govern the flow of matter across light years. Every now and then, something extraordinary disturbs that stillness. A nearby supernova can send a shockwave rippling through space for hundreds of light years. The wave sweeps up material as it goes, compressing gas and triggering new rounds of star formation. In this way, the death of one star becomes the birth of many others. The galaxy is filled with supernova remnants, expanding shells of gas that glow faintly in radio waves and X-rays, each one marking the place where a massive star once ended. There are also regions of the Milky Way where stars are packed together far more tightly than in our quiet neighborhood. Near the center of the galaxy, stars crowd so closely that their light merges into a golden haze. Here, the pull of gravity is intense. Stars move at incredible speeds around the supermassive black hole at the core, their orbits traced by years of patient observation. The density of stars near the center is millions of times higher than in our region of the galaxy. If Earth orbited a star near the galactic core, the night sky would be filled with thousands of stars brighter than Venus, and the darkness between them would glow softly with the combined light of billions more. Around the edges of the galaxy, things are much calmer. The halo contains old stars, remnants of galaxies long ago absorbed by ours. Some of these stars follow looping orbits that take them far above and below the disk, carrying them through regions of near emptiness before returning to the galactic plane. They are the fossils of the Milky Way's youth, moving quietly through space, untouched for billions of years, witnesses to the galaxy's entire history. If we could see the galaxy in motion, truly see it, not just in a single moment but across millions of years, we would find that it moves like a living thing. Gas flows inward toward the center, feeding the black hole and forming new stars. Stars are born and drift outward, their light gradually fading as they age. Supernovae blow bubbles in the gas, clearing vast cavities that slowly refill. The entire disk ripples and bends in slow rhythm, responding to the pull of dark matter and the passage of companion galaxies. The Milky Way breathes on a timescale far beyond our own, inhaling gas from its surroundings, exhaling energy and heavy elements through supernovae and stellar winds. It is a self-sustaining system, recycling its matter endlessly, turning simple hydrogen into the complex array of elements that make up everything we know. Every atom in your body has been through this cycle, passing through stars and space, clouds and planets, before arriving here, in this moment, in this form. Sometimes I wonder what it would be like to drift through that space, to sail past a newborn cluster where bright young stars carve cavities in the surrounding gas. The light would be both blinding and soft, scattered by the dust around it, painting the clouds in shades of red and blue. In another region, the remains of an ancient supernova would stretch like a ghostly veil, faint wisps of gas still glowing from the energy released thousands of years ago. Every direction would reveal history written in color and light, each structure a chapter in the galaxy's ongoing story. From our small planet, we can only glimpse a narrow piece of this vast system, but even that glimpse is enough to remind us how much more lies beyond. When I look through a telescope and see the faint glow of a nebula, I am looking not only at gas and dust, but at time itself, at something that began long before the Earth existed and will continue long after it is gone. The light carries information across the centuries, arriving here to tell us of distant processes, of stars being born and dying, of matter transforming in the endless cycle that drives the galaxy forward. In the quiet between stars, something remarkable is always happening. The space that appears empty to our eyes is filled with tenuous gas, fine dust, and complex molecules drifting through the darkness. This interstellar medium, as astronomers call it, contains the raw material from which stars and planets form. It is thin beyond imagination, far emptier than the best vacuum we can create on Earth, yet it fills every corner of the galaxy, connecting star to star across vast distances. The gas consists mostly of hydrogen, the simplest and most abundant element in the universe. In some regions, this hydrogen is cold and neutral, atoms drifting alone through space, at temperatures only a few degrees above absolute zero. In other places, it is ionized by the ultraviolet light of nearby young stars, glowing in shades of red as electrons recombine with protons, releasing photons in the process. These glowing clouds, called HII regions, mark the locations of recent star formation, visible as pink and red nebulae in photographs of the Milky Way. Between these extremes lies molecular hydrogen, where pairs of hydrogen atoms bond together in the cold and dark. These molecular clouds are the birthplaces of stars, regions so cold and dense that gravity can overcome the pressure of the gas and cause it to collapse. Inside the darkest, densest parts of these clouds, temperatures drop below 10 degrees Kelvin. Here, shielded from starlight by layers of dust, complex chemistry unfolds. Astronomers have discovered more than 200 different molecules in interstellar space, ranging from simple pairs like carbon monoxide to complex organic compounds containing dozens of atoms. Water, ammonia, methanol, formaldehyde, and even amino acids have been detected in molecular clouds. These molecules form on the surfaces of dust grains, tiny particles of carbon or silicate that serve as platforms where atoms can meet and bond. Over millions of years, layer by layer, these grains accumulate icy coatings, rich in organic molecules. When a molecular cloud collapses to form a new star system, these dust grains are incorporated into the rotating disk around the young star. Some are vaporized by the star's heat, releasing their molecules into the gas. Others drift farther out, into the cooler regions where planets form. In this way, the complex chemistry of interstellar space is delivered to newborn worlds, providing the raw materials from which oceans, atmospheres, and perhaps life itself can arise. It is entirely possible that some of the material that led to life on Earth was forged far from here, in clouds that formed and dispersed long before our solar system was born. The water in our oceans, the carbon in our cells, the nitrogen in our DNA, all of it cycled through interstellar space, drifting in clouds, gathering on dust grains, waiting for gravity to pull it together into something new. That idea brings me comfort. It means that the galaxy itself is creative, not merely hosting life, but actively creating the conditions that make life possible. In its vastness, there is an unbroken continuity between the stars and the living beings that arise among them. We are not separate from the cosmos, but deeply connected to it, built from its dust, animated by its energy, part of its ongoing transformation. Even the smallest details of the Milky Way tell this story of connection. Cosmic dust, which drifts between the stars, dims and reddens the light we see. From a distance, it might seem like an obstacle, something that hides the galaxy's true form. But without it, there would be no planets, no oceans, no people. Dust is the raw material from which everything solid is made, each grain a tiny archive of the galaxy's history, a fragment of something that once burned as a star. The dust forms in the atmospheres of dying stars, condensing from vaporized rock and metal as the star's outer layers cool and expand. Red, giant stars puff shells of gas and dust into space, gradually shedding their mass over millions of years. Supernovae blast dust outward at thousands of kilometers per second, mixing it with the gas of the interstellar medium. Over time, this dust accumulates, gathering into clouds that block visible light but glow softly in infrared wavelengths. Inside those clouds, the dust plays a crucial role in star formation. It absorbs ultraviolet light from nearby stars, protecting the cold gas from being heated and dispersed. It also provides surfaces where molecules can form, speeding up chemical reactions that would be impossibly slow in the gas phase alone. Without dust, molecular clouds could not remain cold and dense enough to collapse into stars. In a very real sense, dust makes the galaxy fertile, enabling the cycle of star formation that has continued for billions of years. Magnetic fields thread through the interstellar medium, invisible but influential. These fields are weak by laboratory standards, thousands of times weaker than a refrigerator magnet. But they span light years, guiding the motion of charged particles and shaping the structure of gas clouds. When a cloud begins to collapse, the magnetic field can slow the process, threading through the gas like a web, providing support against gravity. Eventually, as the gas grows denser, the field becomes compressed and amplified, playing a role in how the collapsing cloud fragments into individual stars. Cosmic rays, high-energy particles accelerated by supernova shock waves and other violent events, stream through the galaxy at nearly the speed of light. They collide with gas atoms, ionizing them, and providing a source of energy even in the darkest clouds. These cosmic rays help determine the temperature and chemistry of the interstellar medium, influencing everything from the rate of star formation to the survival of complex molecules. They are a form of background radiation that pervades the galaxy, invisible but ever present, a reminder that even in the spaces between stars, energy flows constantly. All of this unfolds silently. The motions are too slow for us to notice, the distance is too great for us to cross. Yet from our small vantage point, we can still feel part of it. Every breath, every heartbeat, every thought takes place within this larger rhythm. The galaxy spins, stars are born, others die, and we continue to move with it through the darkness. Participants in a story that began long before we existed and will continue long after we are gone. When I stand beneath the night sky, I sometimes imagine what it would sound like if we could hear the galaxy. Not in the way we hear air move on Earth, but in the low, slow music of gravity and light. Perhaps it would be a deep hum, steady and endless. The sound of billions of stars orbiting, gas clouds collapsing, magnetic fields twisting through space. Or maybe it would sound like silence, the kind of silence that feels alive, filled with potential and motion too subtle for our senses to detect directly. The Milky Way has been singing this quiet song since the beginning. We are part of it, woven from the same matter, shining for a little while, then returning to the whole. The stars that will come after us will carry a little of our atoms in them. The galaxy remembers everything, just not in the way we do. It remembers through recycling, through transformation, through the endless flow of matter from star to space, to star again. As the night deepens, imagine that you could drift upward and see the entire disk spread below you. A spiral of light stretches across the darkness, blue along the arms where new stars burn hot, golden near the center where old stars rest. Around the edges, faint traces of dust and dark matter fade into emptiness. From that height, you would see how gently the Milky Way moves, how patient its rhythm truly is, how each part fits together into a coherent whole. The galaxy's story is not just about stars and space, but about time and transformation. It reminds us that everything changes, yet everything remains connected. The matter that built the first stars still moves through the Milky Way today, taking new forms, shining in new ways. Nothing here is ever truly lost. Atoms are neither created nor destroyed, but endlessly recycled, passing through stars and planets, gas and dust, before becoming part of something new. This continuity extends to us. The carbon atoms in our bodies were made in stars that died billions of years ago. Those atoms drifted through space, gathered into a cloud, collapsed into our solar system, and eventually found their way into living things. One day, those same atoms will return to space, perhaps to be incorporated into new worlds, new stars, new forms of existence we cannot yet imagine. In this way, the galaxy is not just a place, but a process, an ongoing cycle of creation and destruction that has no true beginning or end. Every star is temporary, every planet ephemeral, yet the pattern continues. The Milky Way will outlive us all, persisting for trillions of years after the last human has vanished, continuing its slow rotation through the cosmos. But for now, in this brief moment of awareness, we can look up and see it. We can trace its arc across the sky, feel the ancient light falling on our skin, and know that we are part of something far greater than ourselves. The galaxy does not need us to exist, yet it has made us capable of understanding it, of wondering about our place within it, of feeling awe at its vastness. That capacity for wonder is perhaps the galaxy's greatest gift to us. Through us, it becomes aware of itself. Through our eyes, the universe looks back and sees its own beauty reflected. We are the means by which the cosmos comes to know itself. Matter organized into a form that can ask questions, that can seek answers, that can feel reverence for the mystery of existence. The interstellar medium, thin and invisible as it is, connects us to all of this. The gas we breathe was once part of a distant cloud. The dust that built our world drifted through space for eons. Every molecule, every atom, carries a history written in the structure of the galaxy itself. To study the space between stars is to study our own origins. to trace the path that led from the Big Bang to the formation of conscious life. When I think about the Milky Way, I sometimes imagine stepping outside it, drifting far enough into the dark that I can see it whole. From that distance, it looks like a glowing whirlpool, arms of starlight curling outward through the black. It is only one among countless others, a single luminous island in an ocean of galaxies that stretches as far as we can see. Each of those galaxies is like ours in some way, made of stars, gas, dust, and dark matter. Yet each one tells its own story. Some are spirals, their arms wide and open, traced by young blue stars. Others are elliptical, smooth and ancient, filled with old red stars that have long since stopped forming new generations. Some are small and irregular, faint smudges of light scattered like embers across the darkness. The Milky Way is part of this family, connected to the rest by the invisible threads of gravity. Our galaxy belongs to a small cluster known as the Local Group. It contains about 60 members, though most are faint dwarf galaxies containing only a few billion stars. The largest are the Milky Way and Andromeda, followed by a smaller spiral called the Triangulum Galaxy. Around them orbit dozens of smaller companions, including the Magellanic Clouds that drift just beyond our edge, visible as pale smudges from the southern hemisphere. These galaxies interact in subtle ways. Their gravity pulls at one another, shaping orbits and creating streams of stars that stretch across space. Some of the smallest companions are slowly being absorbed into the larger galaxies, their stars scattered like trails of memory. Even now, our Milky Way is in the process of consuming several of them, adding their mass to its own. From our vantage point, Andromeda appears as a faint smudge in the constellation of the same name. Through a telescope, its spiral structure comes into view, light from over 1 trillion stars arriving after a journey of more than 2 million years. That light left Andromeda when our earliest human ancestors were just beginning to walk upright on the African plains. The galaxy we see tonight is not as it exists now, but as it was in the distant past. Its light, a messenger from across the void. Andromeda is moving toward us at about 110 kilometers per second. The distance between us shrinks by about 300,000 kilometers every day. Someday, it will no longer be a distant companion, but part of the same whole. If we could fast forward through billions of years, we would watch as the two galaxies draw closer, their shapes distorting, long tails of stars extending into the void as tidal forces pull them apart. Over time, they will pass through one another, their stars rarely colliding, but their gravity weaving them together like two clouds of smoke intermingling. Gas clouds will collide and compress, triggering bursts of star formation that briefly light up both galaxies with brilliant young stars. After the first pass, the galaxies will separate again, but gravity will pull them back. They will pass through each other a second time, then a third, each encounter mixing them more thoroughly. Eventually, after several billion years of this cosmic dance, they will merge into a single, larger galaxy. The spiral arms will be disrupted, replaced by a new shape, perhaps an elliptical galaxy, smooth and featureless, or perhaps a new kind of spiral with a different structure. The merged galaxy will settle into equilibrium, its stars continuing to orbit in quiet harmony, though in patterns very different from what we see today. Though it sounds like a cosmic ending, it is really just another beginning. The merged galaxy will settle into a new form, its stars continuing their journeys through space. Star formation may continue for billions of years, fed by gas that hasn't yet been consumed or blown away. The universe does not destroy, it transforms, turning old patterns into new ones, continuing the cycle that has been unfolding since the first galaxies formed more than 13 billion years ago. Beyond our local group lies the Virgo cluster, a region of space containing more than 1,000 galaxies. It sits about 50 million light-years away, and its gravity pulls gently on us even now. The Milky Way and Andromeda, together with all our smaller neighbors, are drifting toward it, falling slowly into its gravitational embrace. We will never reach it in the lifetime of the Sun. It would take tens of billions of years to cross that distance, but we move with it as part of a greater flow. Astronomers have discovered that the Virgo cluster itself is only one part of a still larger structure. When they mapped the motions of thousands of galaxies, they found that they all move within a vast network that spans hundreds of millions of light-years. They called it Laniakea, a word from Hawaiian that means immeasurable heaven. The Milky Way lies deep within this supercluster, carried along by gravity like a leaf on a vast current. If we could see the universe at this scale, we would notice that galaxies are not evenly spread out. They form long filaments and clusters, separated by enormous voids containing almost nothing. These filaments are like the strands of a cosmic web, stretching across space for billions of light-years. The Milky Way sits on one of those strands, connected to the rest by the quiet pull of matter, part of a structure so large it defies comprehension. Within this web, galaxies are not isolated. They move together, drawn toward regions of greater mass, while the space between them expands as the universe itself grows larger. Gravity gathers matter into patterns of surprising beauty and regularity. Even the emptiest regions are part of the design, shaping how galaxies form and where they cluster, creating a balance between matter and void that extends across the observable universe. The Milky Way's motion through this landscape is almost beyond comprehension. Relative to the cosmic microwave background, the faint radiation left over from the Big Bang, we are moving at more than 600 kilometers per second. The entire local group is falling toward a region known as the Great Attractor, a concentration of mass partly hidden by the dust and stars of our own galaxy. Farther still, the whole structure is moving toward an even larger concentration of galaxies, called the Shapley supercluster. The universe is in constant motion on every scale, from the smallest dust grain to the largest superclusters. Even though we are part of this vast flow from Earth, the sky appears calm. The stars rise and set in familiar patterns. The constellations drift slowly over millennia, but nothing hints at the speed with which we travel through the cosmos. The peace of the night sky hides the immensity of our journey, the countless motions that carry us through space on paths we cannot feel. Sometimes I imagine what it would look like if we could trace our path through the universe. Every second, Earth moves around the Sun. The Sun moves around the Milky Way. The Milky Way moves toward Andromeda, and together they move through the cosmic web, following currents of dark matter that span distances larger than we can easily visualize. Our motion is a spiral, within a spiral, within a spiral, a graceful pattern of endless travel through dimensions we can barely conceive. There is a quiet wonder in knowing that even as we sleep, our world crosses interstellar space at unimaginable speed. The stars we see above us are companions in motion. We are all travelers together, moving through the same cosmic ocean, drawn by the same invisible forces. Though the universe is vast and we are small, we share in its motion, participating in flows that connect us to every other galaxy, every other star. As we move through the universe, we also look deeper into it. Every time we build a more powerful telescope, we see farther back in time. Light takes time to travel, so when we observe distant galaxies, we are seeing them as they were billions of years ago. The most ancient light we can detect comes from when the universe was only 380,000 years old, when atoms first formed and photons could finally travel freely through space. It glows as a faint background in every direction, the afterimage of creation itself. That light, called the cosmic microwave background, reveals tiny variations in temperature and density, the first seeds from which galaxies like ours would eventually grow. When I think about that, I realize that everything we see today, every star and planet, began as small ripples in that ancient glow. The Milky Way, Andromeda, and all the galaxies in the cosmic web trace their origins back to those early fluctuations, imprinted on the universe when it was still hot and dense. Our galaxy, then, is not just a local structure. It is part of a universal story that began with those ripples nearly 14 billion years ago. The same physical laws that shaped the Milky Way shaped every other galaxy. The same gravity that guides the stars in our sky also pulls on galaxies billions of light years away. The same dark matter that holds our galaxy together forms the scaffolding on which the entire cosmic web is built. When I consider this, I feel the familiar line between here and there dissolve. There is no real boundary between our galaxy and the rest. Everything connects through gravity and time, through light and matter. We are threads in the same cosmic fabric, woven from the same primordial substance, part of a pattern that extends from the smallest subatomic particle to the largest structures in the universe. The night sky is a map of this connection. Each point of light is a reminder of distance, but also of unity. The Milky Way arches across the heavens like a bridge between the near and the far. It reminds us that our home is both small and vast, both one place and all places at once. We live within a galaxy that is itself part of a cluster, which is part of a supercluster, which is part of a web that fills the universe. Sometimes, when the sky is clear and the horizon is dark, I look at that faint milky band and try to imagine all the galaxies beyond it. Each one holds billions of stars, and around many of those stars, planets circle quietly. On some of them, life might be looking back, wondering the same things we do, feeling the same awe at the vastness and beauty of the cosmos. It is possible that consciousness has arisen many times across the universe, each instance a way for matter to know itself. The light we see from distant galaxies might one day reach another mind, one that looks upon it with the same wonder. In that sense, we are part of a conversation that spans all of time and space, a dialogue between conscious beings separated by impossible distances, yet connected by the same impulse to understand. When I look up at the Milky Way, I sometimes think of it not as something far away, but as something I am inside of. Every breath, every sound, every thought takes place within its light. The stars above are not distant objects separated from us by empty space. They are part of the same great structure that carries us through the cosmos, connected to us by gravity and history, and the shared substance from which everything is made. It is easy to forget that the ground beneath us is part of the galaxy too. The rocks, the oceans, the air we breathe, all of it formed from ancient stardust, gathered over billions of years from clouds that once drifted between the stars. The atoms in our bodies once floated freely in space, part of vast nebulae that collapsed to form new suns and planets. To exist is to be part of the Milky Way, to participate in its ongoing story of transformation and renewal. We often imagine galaxies as distant objects, but they are living systems that grow, change, and interact with their surroundings. They are not static collections of stars, but dynamic structures, constantly recycling matter through generations of suns, creating the conditions for complexity to arise. And through those slow transformations, they create the ingredients for life. Somewhere within the Milky Way's spiral arms, the matter that became Earth gathered together 4.5 billion years ago. It was not the first world to form in our galaxy. Countless others had already taken shape over the previous 9 billion years. But it was the one where, through a combination of chance and chemistry, life emerged and eventually gave rise to consciousness, to minds capable of looking outward and wondering about their place in the vastness. The Milky Way has seen more than we can imagine. It has survived collisions with smaller galaxies, absorbed their stars, and continued growing. It has watched the universe expand around it, carrying it along in flows too vast to perceive directly. It has created trillions of stars, each one a potential hearth for worlds and perhaps for life. Yet here we are, small beings on a quiet planet, able to look back at it and see the pattern it makes, able to understand our origins in its dust and light. In that way, we are the galaxy becoming aware of itself. The matter that makes up our bodies and brains was forged in stellar furnaces, scattered by supernova, gathered by gravity into this small blue world. Through us, the universe opens its eyes and sees. Through us, it asks questions about its own nature, seeks to understand the laws that govern its behavior, wonders at the beauty and mystery of existence. When I think of that connection, I feel the strange comfort of belonging. We are not separate from the stars. We are their continuation, their legacy, their children. The light that burns in them is the same energy that drives our thoughts, our warmth, our lives. The calcium in our bones was made in supernova explosions. The iron in our blood was forged in the cores of massive stars. Every element heavier than hydrogen and helium came from stars that died before our solar system was born. This is not metaphor or poetry. It is literal truth. We are stardust arranged in a way that allows it to think and feel and wonder. The atoms that make up your hand were once part of a star. The molecules in your brain were once scattered across light years of space. You are the galaxy looking at itself, matter organized into a form capable of awareness. The galaxy moves through the universe silently, drifting among billions of others, pulled by gravity and guided by invisible forces that shape the cosmos. The stars within it rise and fade, but the whole continues. It is an unbroken story of transformation, written in light and motion, spanning timescales that dwarf human comprehension. In the heart of every star, hydrogen becomes helium through nuclear fusion. In the death of those stars, heavier elements are cast into space. Those elements gather to form planets. On some of those planets, chemistry turns into life. And from that life, curiosity emerges, the need to look up and ask what it all means, to seek understanding, to find connection with the larger universe. Perhaps that is the purpose of consciousness, to give the universe a way to reflect on itself. The Milky Way has no voice, yet through us it can speak. Through our science and art, our questions and dreams, the galaxy expresses its complexity, its beauty, its ongoing process of becoming. We are its thoughts, its questions, its awareness made visible for a moment in cosmic time. When I picture our galaxy, I see its spiral arms as pathways of connection, linking past to future, matter to energy, simplicity to complexity. Within them, billions of stories are unfolding at this very moment. Stars are forming in cold clouds, planets are cooling and solidifying, moons are settling into orbits, and perhaps, on worlds we cannot yet detect, other forms of life are emerging, opening their eyes to their own skies, beginning their own journeys of discovery. Somewhere in the galaxy, maybe far away, other beings might be looking up at their sky, seeing the same arc of light we call the Milky Way, and wondering about their place in it. They might have different forms, different thoughts, different ways of understanding, but they would share with us the fundamental experience of being part of something vast and beautiful, of feeling both small and significant at once. It is humbling to realize that the universe is not quiet because it is empty, but because it is vast beyond measure. Its scale absorbs our noise, our brief flickerings of light and sound, yet everything we do is real, is meaningful, is part of the whole. The silence is full of energy, full of potential, full of transformations happening on timescales, both infinitely slow and impossibly fast. We often search for meaning among the stars, looking outward for purpose or validation. But perhaps the meaning is already here, embedded in the act of looking itself, in the curiosity that drives us to understand, in the wonder we feel when we contemplate the cosmos. The universe does not need us to be large or important. It needs us to be aware, to notice, to care about understanding. And in that awareness, we fulfill a role that nothing else in our corner of the galaxy can fill. All around us, the Milky Way continues its slow rotation. Our solar system travels its path around the center, drawn by the same gravity that guides every other star. Each orbit takes hundreds of millions of years. To the galaxy, our entire recorded history is barely a flicker. Yet that flicker contains music and poetry, love and discovery, suffering and joy, proof that even a brief light can hold infinite depth. There is a calm beauty in knowing that we are temporary, yet part of something that endures. The atoms that make up our bodies will someday move on, carried by wind and water and time, until they return to the galaxy that made them. In that sense, nothing of us is ever truly lost. We change form, but the substance remains, cycling endlessly through the great system that gave us birth. As the Milky Way turns, new stars continue to form somewhere in its spiral arms. Perhaps at this very moment, a new sun is being born in a cloud of dust, its light just beginning to shine. Around it, rings of gas are beginning to take shape, forming worlds that will one day host their own stories. The same cycle that once gave birth to our world continues without pause, creating possibilities we cannot yet imagine. When I let my mind drift across these scales of time, I find a stillness that feels both infinite and familiar. The same laws that shaped galaxies govern the atoms in our hands. The same light that shines from distant stars falls gently on the surface of our world. There is no real boundary between the cosmic and the human. It is all one unfolding story, all one process of transformation and becoming. Perhaps the Milky Way teaches us not to look for separation, but for connection. Every particle, every photon, every heartbeat participates in the same flow of energy that moves through the universe. To live is to be part of that flow, to feel its movement and carry it forward for a little while, before passing it on to whatever comes next. When I look at the night sky, I often think of how much light has traveled to reach us. Some of the photons entering our eyes began their journey before humanity existed, crossing the galaxy for tens of thousands of years, surviving dust and distance, only to end their voyage in this one quiet moment of seeing. That realization makes the sky feel more intimate. The light of those stars is not only ancient, it is personal, connecting us across time in a way that transcends language and understanding. It reminds us that every instant of awareness is also part of something vast and ongoing, a moment in a story that has no true beginning or end. The Milky Way will not last forever. In billions of years, it will merge with Andromeda, and its spiral shape will fade, replaced by a new form that we cannot yet predict. The stars will continue to shine for a while, then slowly die out as the universe grows colder and darker. Gas will be exhausted, star formation will cease, and the galaxies will gradually fade into darkness. Yet even that is not truly an ending. The matter and energy will remain, perhaps to create again in ways we cannot yet imagine. The universe is patient beyond measure, working on timescales that make billions of years seem brief. What seems like an ending from our perspective may be only a transition to a new phase of existence, a transformation we lack the language to describe. We often speak of the universe as something out there, beyond us, separate from our daily lives. But the truth is simpler and more profound. We are the universe, thinking and feeling and watching itself unfold. The same forces that move galaxies also move through us. The same energy that lights the stars gives life to our thoughts and dreams. To fall asleep under the Milky Way is to return to that awareness, to rest inside the vastness that gave us birth. So tonight, as you close your eyes, remember that you are part of something ancient and beautiful. The same forces that move galaxies also move through you. The same energy that burns in the stars gives life to your heart and mind. The universe is not beyond your reach. It is here, within you, shining quietly, waiting to be known. You are the galaxy dreaming, consciousness arising from matter, light becoming aware of itself. As the night deepens around you, let your thoughts drift upward with the starlight. Imagine yourself rising gently from the earth, lifting above the atmosphere, above the clouds, into the quiet darkness of space. Below you, the planet turns slowly, blue and white against the black. Above you, the stars begin to multiply, more and more of them appearing. As the air thins and the sky grows transparent, you continue to rise, passing the orbit of the moon, leaving Earth behind as a bright star among many. The sun grows smaller, becoming just another point of light. Around you, the solar system spreads out, planets tracing their ancient paths, asteroids drifting in their belts, comets falling inward from the distant reaches. But you keep rising, lifting out of the solar system entirely, watching as the sun becomes one star among thousands. The familiar constellations begin to lose their shapes as you see them from new angles. Stars that seemed close together from Earth are revealed to be at vastly different distances, scattered through three-dimensional space. You rise higher still, and now you can see the structure of the galaxy beginning to emerge. The stars are not randomly scattered but flow in great streams and clusters. You can see the spiral arms taking shape, traced by the blue-white glow of young suns. The central bulge glows golden with the light of older stars, while dark lanes of dust wind between the arms. From this height, the Milky Way looks like a vast river of light, slowly turning in the darkness. You can see our sun, a modest yellow star in one of the smaller arms, impossibly tiny among hundreds of billions of others. Yet it is there, still shining, still warming its family of planets, still carrying us on our long journey around the galactic center. The galaxy turns beneath you, patient and immense. You watch as stars move in their orbits, as clouds of gas collapse into new suns, as the spiral arms rotate slowly through the disk. Time seems to flow differently here, measured not in seconds but in millions of years, in the long, slow rhythms of stellar birth and death. And you realize that you are not separate from what you see. The atoms that make up your body came from that galaxy. The light that enters your eyes is the same light that has traveled across those vast distances. You are not an observer standing apart from the universe, but a part of it, matter temporarily organized into a form that can witness and wonder. Imagine now that you could see not just light, but time itself. The galaxy's past spreads out before you like layers in rock, each era visible at once. You see it forming from the merger of smaller clouds of stars, growing through collisions, developing its spiral structure over billions of years. You watch stars being born and dying, their light flickering on and off like fireflies in a vast, dark meadow. You see the first stars, massive and short-lived, exploding to scatter their elements through space. You see the second generation forming from enriched gas, developing planetary systems for the first time. You see worlds cooling and solidifying, oceans forming. The first, simple life emerging in warm, shallow seas scattered across thousands of star systems. And you see our own solar system taking shape, condensing from a cloud that had drifted through space for eons. You watch Earth form, cool, develop its oceans and atmosphere. You see life arise and diversify, filling the world with forests and seas, with creatures of every imaginable form. And finally, you see consciousness emerge, minds capable of looking back at the stars and understanding, at least in part, where they came from. All of this is contained within the Milky Way, written in its light and motion, preserved in the atoms that cycle through it endlessly. The galaxy is not just a collection of stars, but a vast archive of history, every atom carrying memory, every photon a messenger from the past. As you float in this space between Earth and infinity, you feel a deep peace settling over you. There is no need to understand everything, no pressure to hold on to any particular thought. The galaxy has been here for billions of years. It will continue for billions more. Your presence within it is brief but real, significant but not separate from the whole. You begin to descend now, drifting slowly back toward that small blue world. The galaxy recedes above you, but you carry it with you, knowing that you are made of its substance, sustained by its light, part of its ongoing story. The stars grow dimmer as you enter Earth's atmosphere, but you know they are still there, still shining, still carrying out their ancient rhythms. You settle gently back into your body, back into the present moment, back into the quiet darkness of night. But something has changed. The boundary between yourself and the universe feels thinner now, more permeable. You understand that to rest here, on this small world, is also to rest within the galaxy itself, cradled by the same forces that shape stars and planets, moons and nebulae. The Milky Way arches overhead, that familiar band of light crossing the sky. But now, when you look at it, you see not just distant stars, but your own history, your own family, the source from which you came and to which you will one day return. Every star is a hearth fire, every planet a potential home, every atom a traveler on an endless journey through space and time. There is comfort in this vastness. You are small, yes, but you are not separate. You are part of the largest story ever told, a story that began with the Big Bang and continues through every moment, every breath, every heartbeat. Your life, brief as it is, contributes something irreplaceable to the universe: awareness, wonder, the capacity to know and to care. As sleep begins to approach, imagine yourself dissolving gently into starlight, your boundaries becoming soft and indistinct. You are the Milky Way, looking back at itself through these eyes. You are matter that has learned to think, to feel, to marvel at its own existence. There is no difference between the light of those distant suns and the light of awareness that shines within you. It is all one light, one energy, one unfolding mystery. Let go of any need to hold on to thoughts or images. Let yourself drift like a particle of dust between the stars, weightless and free, carried by currents you cannot see but can trust completely. The galaxy knows how to hold you. It has been cradling matter for billions of years, shaping it into stars and worlds, into life and consciousness, into this moment of quiet rest. Your breath slows and deepens, synchronizing with the slow rotation of the galaxy itself. Each inhale draws in stardust. Each exhale releases it back to space. You are part of the breathing cosmos, part of the slow exchange of matter and energy that sustains everything. The stars above grow dimmer as your eyes close. The last thing you see is that faint river of light, the Milky Way, stretching across the darkness like a path leading home. And in a way, it is home. Not just the small blue world beneath you, but the entire galaxy, the whole vast structure of light and dark, matter and energy, birth and transformation. You are safe here, held by gravity and time, part of something far greater than yourself, yet intimately connected to every particle of your being. The universe cradles you as it cradles stars, with patience and presence, with laws that never fail, with a vastness that has room for everything. As you drift towards sleep, remember, You are the Milky Way. You are stardust dreaming. You are the universe becoming aware of its own beauty. Rest now, knowing that every atom of your being is exactly where it belongs, part of the great turning wheel of stars, part of the endless story that has no beginning and no end, only transformation, only becoming, only light moving through darkness toward dawn. Thank you for joining this journey through the Milky Way. May the calm of the cosmos stay with you, wherever your dreams may wander next. May you remember that you are part of something ancient and beautiful, something that will continue long after we are gone, carrying forward the light we briefly held. Rest well, traveler. Rest among the stars.